In this video, we are going to learn trigonometric identities. We have 4 trigonometric identity here. I'm not going to explain none of them, but sine squared x plus cosine squared x, y is equal to 1. I'm going to explain that one. Before starting sine squared x plus cosine squared x, let me explain what is sine squared x means. Sine squared x means sine x times sine x. When you multiply two terms here, sine x and sine x, you will get sine square x. So we are not writing the square here, we are writing over n. Then we are understanding sine x multiplied by itself two times. Okay, after this explanation, if you remember, on the right triangle, when you choose your angle here, this is x, this is a, b, and c. We know a square, a over c, or sine alpha is sine x is equal to a over c, and cosine x is equal to b over c. It's going to be. Then sine square x. By the way, I need to remind about this one. A squared plus b squared, if you remember, it's equal to c squared. It's going to be. This is also the Pythagorean theorem. Okay, now I'm going to explain why sine square x plus cosine square x is equal to 1. Sine square x means, if you remember, it's equal to sine x square plus cosine x square is equal to 1. Then here sine, let's say it's not equal to 1. We are going to show that it's equal to 1. Then this is going to be equal to a over c square plus b over c square. Then this is going to be equal to a square over c square plus b square over c square. Then when the denominators are same, c square and c square, the numerators we are going to add, and it's going to be equal to a square plus b square over c square. If you remember Pythagorean theorem, a square plus b square is equal to c square in the right triangle. So this is equal to c square over c square. That's why it's equal to 1. This is the simple proof of sine square plus cosine square x is equal to 1. Here, sine x and cosine x, tangent x is equal to sine x over cosine x. I explained this one, and I didn't prove that one, but here, let me prove sine x is equal to a over c and cosine x is equal to b over c. So sine x over cosine x, over cosine x, it's going to be equal to a over c over b over c. Then the first one is written inners, outers rule, we can say, or the first one is written directly. The second one is you will reverse numerator and denominator, then you will write. Then c and c, when you simplify, the left result is equal to a over b, which is equal to tangent alpha, because a over opposite over adjacent of alpha, it's going to be. So this is tangent alpha. So sine x over cosine x is going to be tangent alpha. If you continue for the cosine, you're going to get the same thing. Tangent x times cotangent x is equal to 1, because sine x over cosine x times cosine x over sine x, when you multiply them, sine and sine you will simplify, cosine and cosine you will simplify. This is the last one, and we are rarely using these functions, secant and cosecant x, and we are going to use only in trigonometric identities this one. 1 over cosine x is equal to secant x, 1 over sine x is cosecant x. If you want to remember, maybe you will remember like this: secant x, it starts with s, and the sine is here, the 1 over cosine. Cosine is start with c. So s, c, c, s, it's going to be. Okay, let's start to solve questions about the trigonometric identities. We have two types of trigonometric identity here. One of them is simplify the trigonometric identity. Here, cosine x times tangent x, we are going to simplify and we are going to find a result for this one. Now I'm writing this cosine x times, if you remember, tangent x is equal to, here, tangent x is equal to sine x over cosine x. In the previous page, here, tangent x is equal to sine x over cosine x. So, if it is like that, then here you can simplify this too, and the result it will be equal to sine x. So, cosine x times tangent x is equal to sine x. This is the most simplified form. Okay, let's continue to simplify the terms. Cosine cube x plus sine square x times cosine x is equal to what? Here, cosine cube can be written like x cube or a cube, let me tell. A cube is equal to, a squared times a. So, cosine cube can be written as cosine square x times cosine x plus sine square x times cosine x. Here as you see, cosine x and cosine x is common. So you can get cosine x bracket. Then it will be like this. In the bracket, cosine x you separate. And what is the things that left inside the bracket? Cosine square x and plus sine square x. If you remember, sine square x plus cosine square x is equal to, this is equal to 1. So this expression is equal to 1 times cosine x, which is equal to cosine x. Okay. The next one, secant x, cosecant times tangent x. Now, in the simplified questions, we know the trigonometric identities at the beginning. I have written them, and I am going to here write them again. Secant x is equal to 1 over cosine x, and tangent x is equal to sine x over cosine x. So I'll offer you always to write them. First, the sine x, secant x is equal to 1 over cosine x. So instead of this one is equal to 1 over cosine x minus cosine x over sine x over cosine x. It's going to be. Here we have this form, 1 over cosine x minus cosine x. So when you subtract an integer from the rational number, you will multiply the denominator by the integer and you will subtract from the numerator. So this is going to be equal to 1 minus cosine x times cosine x is equal to cosine square x over cosine x all over sine x over cosine x. If the denominators of two rational numbers like a over b and a over b over c over b, if we have the terms like this, then denominators you may simplify. It's not going to affect the operation. It can be equal to a over c. So this one and this one, they are same. I'm going to cancel them. So the answer is going to be equal to 1 minus cosine square x over cosine, sine x. It's going to be. Here we don't have any trigonometric identity, but we have the conclusion of trigonometric identity. What was the sine square x plus cosine square x? It is 1. Okay, when you send the cosine square x to the other side, sine square x, it's going to be equal to 1 minus cosine square x. So sine square x is equal to 1 minus cosine square x, and cosine square x is equal to, and also cosine square x is going to be equal to 1 minus sine square x. There is no need to write that one here. And this is going to be, instead of this one, I'm going to write sine square x. Then it's going to be equal to sine square x over sine x. like a square over a. So this is a times a over a, and the result is going to be equal to a. And here it's going to be equal to sine x times sine x over sine x. And when you simplify these two, the result is going to be equal to sine x. So all this expression is equal to